Okay, in this question, part A, we need to find all first order partial derivatives of this function of two variables, x and y. So you need to find the partial with respect to x, which we can also write as partial of f with respect to x, and f sub y, which is the partial of f with respect to y. Those are the ones they asked us to evaluate. But notice, again, you have a ln in the question, as in previous questions that we had. Whenever you have ln, simplify everything within the ln before you do derivatives or integration, or any question for ln. So notice that this is equal to ln of x squared times y, and ln of a product of two things, when you multiply, it changes this to addition of the two lns, ln x squared plus ln of y. And notice that also ln x squared, you can bring this 2 down. It's a property of ln. So it will be 2 ln of x plus ln of y. And this is much simpler than the way we started with it as ln of a multiplication. This is easier to deal with. And so now what we will do is we'll write the function in the simpler way. So let's do everything in red. Like this now will be equal to 3y times ln of x squared y. We saw that it's equal to this. So times 2 ln x plus ln of y. Multiply inside, so distribute it here and there. You'll get 3 times 2 is 6y ln of x plus 3y ln of y. Okay, good. So now this is our function. This is our f of xy after simplification. We can start with it now and do the partial derivatives. Therefore, first let's start with the partial with respect to x. So you consider y as a constant now and take the derivative with respect to x. So here, 6y ln x, it's 6y, and the derivative of ln x is 1 over x. Okay, plus the derivative of this with respect to x, I see no x's in it. So the derivative is 0 with respect to x. Okay, and so the entire thing is just this, which is, you can just write 6y over x like this. And this is the answer to the partial of f with respect to x. Now, the partial with respect to y. F with respect to y is, and let's now think now in terms of y. So x is the constant. This ln x for us will be a constant. It will remain there. And derivative of 6y is 6 with respect to y. So this will be 6 ln x. Okay, this is like a constant times y. You know, this is the same as like writing 3y, for example, and I tell you what's the derivative, you will tell me the number that's multiplied by y, because the power of y is 1 here. So here the power of y is 1, so you take whatever constant is multiplied by it, which in this case is 6 ln x. Okay, good. Make sure that you understand this part. Plus now this with respect to y, it has two functions of y, so I use the product rule. So this is plus, and now the product rule gives me 4 things, something times something plus something times something, and this is the first function, 3y, so its derivative is 3, and in the second part you need to write it as it is, and ln y, you write it here as it is, and the derivative of ln y with respect to y is 1 over y. Okay, that's just from the product rule. It gave us this as the derivative of this thing here with respect to y. And so, finally, you'll do 6 ln x plus, now, this will be 3 ln y plus, y cancels y here, and you get just 3. So, you can write this as, so if we want to write it in terms of how it was given at the beginning, if you take 3 as a common factor, you'll have 2 ln x plus ln y plus 1. You see? And you can do, this is 3, and then combine 2 ln x plus y. You remember? 2 ln x plus y was ln x squared y. I mean, you're reversing what you did at the beginning. You don't have to, but if you have multiple choice answers, it could be that they give you the final answer as this x squared y. They recombine them again, plus 1. So you can have it like this, actually, fy, simplified. This is simpler than the one above it. Simpler than leaving it like this. Okay, and so let's check our answer for A before going to B. So with your calculator, you can check, of course, your answers. And here, not during the final exam, because this calculator can do more than the Casio calculator you have. But the Casio calculator you have already can check a lot of answers. The only thing is that it cannot do an integral without limits of integration. Your calculator can just do this integral, the one that the Casio that you're allowed to use. You need to give it the limits. Okay, but the one here on the iPad is much more advanced because it can hold more memory here on the iPad, and it's connected to Wi-Fi, and it's updated regularly, so you always get better answers, more simple, and so on. So let's see. Our function here, we want its derivative with respect to x of this. So I will do d by dx of, and now we write the function 3y times ln of, and inside the ln we have x squared y. So x squared and then y equals 6y over x. See? So the first one is correct. And now with respect to y, let's see, the derivative is 3 ln x squared y plus 3. They multiplied it inside, so they get it like this. But I think that the way I wrote it here is kind of simpler, because you take the 3 as a common factor. You don't multiply it inside here and there like they did in the answer. It's okay. It's the exact same answer. So both of them are correct. Perfect. Let's go then to the second part, or part B. And in part B, they want all second order partial derivatives. Notice, when you have a function of two variables and you want second order, it could be one of four things. It could be fxx, or fxy, or fyx, or fyy. This is when you take derivative with respect to x, then with respect to x. This is x first, then y. This is y first, then x. And this is y, then y. This is what they ask us to do. But notice, in order to do them, you need to first do the first order. So let's do fx first. This is a straightforward one. Okay, so you'll see. With respect to x, this is 12x. Plus, with respect to x, notice y squared is a constant for you. But the 3 will come down. 3 times 2 is 6. X squared, and the y squared remains as it is, plus exponential, always without thinking, write it as it is, times, and now ask yourself the exponent. If I take the derivative with respect to x, because I need x in this question, what would it be? 2. If it was with respect to y, you'll put minus 3. Yeah, see? And now this will be 12x plus 6x squared y squared plus 2 times e to the 2x minus 3y. This here is our fx, notice. And so now we can do fxx and fxy, because those come after. So do another derivative with respect to x, but of this. It will be 12 plus 12x, and y squared is like a constant, plus 2, copy the exponential as it is, times the derivative of the exponent with respect to x, again another 2. So this will be 12 plus 12xy squared plus 4 times e to the 2x minus 3y. This is the first one out of the 4 second order partial derivatives. This is the first one. Now we need fx then y. So concentrate here now. This one fxx, now you're done with it. You don't look at it again. You cannot compute anything from it now. So you go back to fx to compute fxy. Now with respect to y, 12x, the derivative with respect to y is 0, plus with respect to y, this will be, the 2 comes down, so 12x squared is a constant, then y, plus 2, copy the thing as it is, 2x minus 3y times, and now the derivative of this with respect to y, it will give me negative 3. So multiply here by negative 3. And so you'll get now 12x squared y minus 6 e to the 2x minus 3y. So here, this is my fxy. Let me highlight it here. So now I have, let's highlight them with this color, fxy and fxx. Those are 2 of the 4. And now let's do, we have to look back now because we did fx and anything that is related to doing x first. Now we want to do y first. So we will take this as it is and concentrate now doing fy. So derivative of this with respect to y, 0, plus, so it will be what, 4x cube y, concentrate, yeah, I did this with respect to y, and now we'll do this with respect to y, exponential remains the same, copy paste, times with respect to y, it's negative 3, the derivative of the exponent, and so this will be 4x cube y minus 3 e to the 2x minus 3y. This is fy. And now from this we can compute fyy and fyx. So let's do fyy. This will be with respect to y. This is 4x cube only. It's like y to the power 1 times a constant. That's why you get just the constant in this one, which is 4x cubed. With respect to y, it's a constant. Minus 3, copy paste to the exponential, and multiply by the derivative of the exponent, which is negative 3. With respect to y, the second time. That's why you get negative 3. If it was with respect to x, you get 2, as we did before. So this would be 4x cubed plus 3 times 3, 9, e to the 2x minus 3y. This is fyy, and we're almost done. Now we just need fyx. Finally, you can say finally fyx equals, and it should be the same as this. So whatever we get, we need to get it the same as fxy. That's the theorem. If the second order partial derivatives are continuous, then fxy and fyx should be the same. So let's see, but we will compute it now. fyx, it means do fy, which you did already here, and now this with respect to x, do it. So let's do this with respect to x. It will be 12x squared y, the derivative of this with respect to x. Remember, the y is a constant with respect to x. Don't forget it. It has to be there. Minus 3, copy paste till e, 2x minus 3y times the derivative of the exponent is 2. And so this becomes 12x squared y minus 3 times 2, 6 e to the 2x minus 3y. Let's compare this, which is fyx that we got, to the one here. Are they the same? 12x squared y minus 6e to the 2x minus 3y. Perfect. So the mixed partial derivatives we got, they are the same. So this gives us, you know, an indication that our answer is correct, but still I want to show you that all the second order partial derivatives we got are correct. So you can do d by dx of d by dx. So this is fxx, and now you write the function 6x squared plus 2x cube y squared plus e to the power 2x minus 3y. Where is the y? Here. Yes. So let's see. The dx by dx twice, so this will give us fxx. Now check this answer. See if it's what we'll get. Equals 12xy squared plus 4 times exponential plus 12. Yes. Now I want fxy to check that it's this. So I'll just put d by dx, and the one outside is with respect to y. Here. And let's see. Equal. Is it the same as this? Let's see. 12x squared y. Yes. And minus 6. Yeah. E to this. Perfect. And now if you put here y and here outside x, you should get the same thing. 12x squared y minus 6 e. Okay, and last one is yy. So I'll put the y here equal. And where did we have it? We got it here. fyy. 4x cube, yes, plus 9e. Perfect. So this shows us that our answers are all correct, and I will stop here.